guys, welcome to our channel Raw and Basic. So in this video we will learn how to solve your logarithmic equations. So before that, let us first identify the basic properties and laws of your logarithms. So on the board we have three basic properties and three basic laws. Okay, so let us first use this or give some examples on how to convert your exponential form into logarithmic form. Okay, so this is very basic for us to know it first before we solve your logarithmic equations. Okay, so assuming we have your exponential form, or this one, 2 raised to 1, of course, is 2. So writing it in log form, we have log. Then the base is 2. The base is 2. Then the exponent is 1. Then the answer of your exponential form is in here. Okay, so we can read it as log of 2 base 2 equals 1, or log base 2 of 2 equals 1. Again, log of 2 base 2 equals 1. Okay, so a logarithm is always equal to the exponent. Again, a logarithm is always equal to the exponent. So the exponent here is 1 and your logarithm is equal to 1. Okay? Let's try this one. So example, we have 2 cubed. Of course, 2 cubed is 2 times 2 times 2, we have 8. Again, log, then equals, the base is 2, the exponent is 3, then what remains is 8. So log of 8 base 2 equals 3. Okay, another example. We have 3 squared. Of course, 3 squared is 9, and that will be log of, the base is 3, the exponent is 2, then remaining is 9. So log of 9 base 3 equals 2. Okay, example, let's have log of 16 base 4 equals 2. So log of 16 base 4 equals 2. So let us convert it into exponential form. So what is the base? So the base is 4. Okay. What is the exponent? So the exponent is the answer of your log. And write 16. So 4 squared equals 16. Okay, last example, we have log of 25. Base 5 equals to 2. So converting into writing it in exponential form, the base is 5. Then the exponent is the answer of your log. So that is 2. 5 squared. Then we have 25. Okay? So it is very basic for us to learn it first before we can solve your logarithmic equations. Now let us proceed to the different properties and give some example for each property and law. Okay, so property number 1, we have log of 1 base b is equal to 0. So I will give you some example. So example, we have log of 1 base 3 equals to 0, of course. Then we have log of 1 base 9. So the correct answer is 0, because if we have to write it in your exponential form, we have 3 raised to 0 equal to 1. Okay, so that's so easy. Then we have 9 raised to 0 is, of course, 1. Any number raised to 0 is equal to 1, except 0, because 0 raised to 0 is 0. Okay, now let's proceed to property number 2. Okay, property number 2, we have log of b base b equals 1. So if you can see, the base in here and the number in here are equal. Okay, so example, we have log of 3 base 3. So if it is the question, what will be the answer? What is the log of 3 base 3? So the log of the number and its base are the same. So the correct answer is 1. In exponential form, we have 3 raised to 1, of course, is 3. So the identity property of log exponent. Okay, so any number raised to 1 is equal to that number. Here, the log of a number with the same base is equal to 1. Another example, we have log of 11, base 11. So what is the answer? So of course the answer is 1. That is 11 raised to 1 is equal to 11. Okay, so very easy. But we should stick to the basic. Okay, property number 3, we have log of b raised to x base b. Okay, so focus on the exponent of your log. The exponent is x, then the base and the log of the number are equal. So the correct answer is x. So example, we have log of 2 raised to 4 base 2. So what will be the answer? Okay, so the log of a number and the base are the same, and then that number has an exponent. So that exponent will be the answer. Okay? Again, example, we have log of 7 squared equal log of 7 squared base 7. So what will be the answer? So the answer, of course, is the exponent. So easy. Okay, so let us not forget these properties, because later we will try to use it to solve your logarithmic equation. Now let us proceed to the basic laws of your logarithms. So first we have your product law. Okay, so the product law speaks that if log of m times n base b is equal to the sum of the logs. So we have log of m base b plus log of n base b. Okay? So this is how to simplify, to expand, and to simplify your logarithms with concern to multiplication of logarithms. Okay? So they are multiplied m and n. So therefore, we have to add m plus n. Okay? So example, we have log of, let's say, 3. Then we have 6m So expanding, we have log of 3, log of 6 I mean, base 3 plus log of m base 3. Okay? Sorry. Again, example, we have log of 6m base 3, and that is equal to log of 6 base 3 plus log of m base 3. Okay? Another example is log of 3x, example, base 2. So we have log of 3 base 2 plus log of x base 2. So easy. Okay? Another example of a law of logarithm is the quotient law. Okay, the quotient law, of course, is the inverse of your product law. So getting the quotient is like log of m divided by n base b is equal to log of m base b minus log of n base b. So product and quotient are inverse operations. So the inverse, of course, of plus is minus. So in getting the product, we will add the logarithm. In getting the quotient, we will subtract the logarithm. Okay? So easy. Example, we'll use this one. Log of 6m base 3 is equal to log of 6 base 3 minus log of m base 3. Okay, so that's very easy. Now let's proceed to the third law of logarithm. We have the power law. So we have log of m raised to n base b is equal to n log of m base b. So if you can see here, the exponent n is multiplied to the log of the number. Okay? Such as, example, we have log of m cubed base 2, and that will be equal to the exponent 3 here is multiplied to log of m base 2. Okay? Another example, we have log of n raised to x base 2 again. So again, the exponent x is multiplied to the log of the number. So easy. Okay, so let us apply this properties and laws in solving your logarithmic equations. Okay, so let us try your first example. On the board, we have log of 3x plus 1 base 2 equals 4. Okay, again, log of 3x plus 1 base 2 equals 4. Okay. In this form of your logarithm and how to solve its solution, because we are solving for the equation and we are finding for the solution. Okay. So in this case, we will solve for x because x is our unknown variable. Okay? If this is the case, we will try to write your logarithm into exponential form. Okay? Again, let us try to rewrite your logarithm in exponential form. So what is the base? So the base is 2 here. And what is the exponent? So the exponent is the answer of your logarithm. So the exponent is 4. Okay? Then we have 3x plus 1. Okay? To continue, let us solve for x. Let us simplify 2 raised to 4. So 2 raised to 4 is 2 times 2 times 2 times 2. And that is 16. So 4 times 4 is 16. Then we have 3x plus 1. Then combine like terms, isolating the term with the x value. So we have 16 minus 1. To eliminate positive 1 in here, we should subtract 1 and subtract 1 on the other side. So therefore 16 minus 1 and positive 1 is eliminated. So we have 3x. Then we have 15 equals to 3x. To eliminate 3, we have to apply the division property of equality. So we have divided 3 on the other side, therefore we have to divide 3 on the other side. Therefore x is equal to 5, or writing it the proper way, we have x equal to 5. Okay? So checking the answer. Checking. So copy your original logarithm. Then substitution, x is equal to 5. So we have log of 3, x is equal to 5 plus 1 equals 4. So we have substitution. Okay? Then continuing, we have log of, so base 2, we have 3 times 5 is 15 plus 1, also 4. Then to continue, log of 15 plus 1 is, of course, we have 16. Then base 2 equals 4. Okay? Then we have log. Okay, 16 can be in the form of, let's try to put your base 2. 16 can be in the form of 2 raised to 4. Okay, so 2 raised to 4 again is 16. So we did not touch the base, which is 2, and we did not touch your right side of your equation, which is 4. So we will just operate on this. So log of 2 raised to 4 base 2 is equal to what? Equal to what? Just focus in here. So using the property number 3, we have log of b raised to x, where the base of x and the base of your log are the same. Therefore, the value of the log as a whole is equal to the exponent. So the exponent in here is 4. So therefore, 4 is equal to 4. So 4 equals 4. True or false? So true. So we can say that x equal to 5 satisfies your logarithm or logarithmic equation. Therefore, x equal to 5 is the solution. Okay, now let us proceed to another example. Okay, on the board we have our second example. We have log of 3, log of x base 3 equals to log of 27 base 3. Okay, so let us solve. Then we have log of x raised to 3. So 3 in here is transferred on the exponent of x. So we have x cubed base 3. Okay, on the other side, we have log of 27 base 3. Okay? So in here, we have applied the power law. Okay? Power law. Next, we have x cubed equals 27. So this is a one-to-one property. We disregarded these things. Because the bases are equal, we will have to solve for x cubed and 27. That is one-to-one property. Just like your exponential function, we are disregarding the bases if the bases are equal. Okay, now let us proceed with x cubed equals to 27. So the best thing that we can do to isolate or solve for x is to eliminate this cube. So to eliminate this cube, we have to use the cube root or to extract the root of x because we have extracted. So therefore, we should extract 27 on the other side of your equation. Again, equal symbol is denoting balance. Okay? Okay, so we have discussed this one. The example, we have x cubed. Cube root of x cubed is equal to x raised to 3 divided by 3. So 3 is here. So 3 divided by 3 is 1. So any number raised to 1 is equal to that number. So therefore, x. The same with this one. You can check using your calculator. The cube root of 27 is, the cube root of 27 of course is just like this one. The cube root of 27 is 3. Okay? So we have extracted the root of 27. Now let us go to checking if x equal to 3 really satisfies your logarithmic equation. So checking using the original equation, we have 3 log of x base 3 equals to log of 27 base 3. Okay? Substitution, we have log base 3 and our x is equal to 3. Then we have log of 27 base 3. Applying your power law, we have log. So we have base 3, then 3 raised to 3. Okay? Power law. Then simplify, we have log 3. 3 raised to 3 is 27. So if you can see, they are equal. So we don't have to simplify it further because we can see that log 27 base 3 is equal to log of 27 base 3. So therefore, x equals 3 is the solution of your logarithmic equation. Okay? Let us proceed to another example. On the board, we have log of 2x base 4 equals to log of 10 base 4. Now let us solve for x. Okay? So what shall we do? Number 3. Okay, so if you can see, the bases are the same. So the bases are 4. So therefore, disregard the log and solve for 2x and 10. And that is your one-to-one property. Very easy. Then solve for x. Isolating x on the other side, we should divide 2. Divide 2, x therefore equals to 5. Checking. Using the original equation, we have log of 2x base 4 equals to log of 10 base 4. Substitution, we have log of 2 times 5 base 4 equals to log of 10 base 4. So we have log 2 times 5 is 10 base 4. Then we have log of 10 base 4. So if we can see, log of 10 base 4 is equal to log of 10 base 4. Therefore, x equal to 5 is the solution of your logarithmic equation. For another example on the board, we have log of x plus 1 base 2 plus log of x minus 1 base 2 equals 3. So if you can see, the logarithmic equation is written on expanded form with the addition of log, or we have this one. Okay? So what's next? So we have to simplify it. That's log of x plus 1 times, log of x plus 1, quantity x plus 1 times x minus 1 base 2. So the property or the law that we are using is the product law. You can see product. We are multiplying x plus 1 and x minus 1. Okay? Just go back to our video. So this is a product law. Then simplifying, we have we have 3, we have 2 raised to 3, or shall we write it as the next step will be converting or writing your logarithmic equation into exponential form. So the base is 2. So the base is 2, the exponent is 3. Again, we will know the exponent is 3 because the answer of your logarithm is always the exponent of this thing. So 2 cubed, so 2 is the base, 3 is the exponent, then what's remaining is x plus 1 times x minus 1. Okay? Simplifying, we will get 2 cubed is 8. Then we have x plus 1 quantity times x minus 1. So using your FOIL method, we will get x squared minus 1. Difference of 2 squares. So if you can see, we have the sum and difference of 2 binomial. So we have x squared minus 1. So product law, then rewriting into exponential form. Then we have multiply binomials. So we get x squared minus 1 equals 8, or 8 equals to x squared minus 1. Okay, so in this case, when you can see this quadratic form, we will equate we will equate your equation into 0. So we have negative x squared. Okay, so to make it more simple, we will put it this way. So we have x squared minus 1 minus 8 equals 0. So to eliminate x, we have subtracted 8, 0. So we have subtracted 8 on the other side, therefore we will subtract 8 on the other side. So that's why we have x squared minus 1 minus 8. Or, to simplify, we have x squared minus 9 equal to 0. Or it can be written as x squared minus 9. It's the same. Again, it is the same. X squared minus 9 equals 0. X squared minus 9 equals 0. Okay? If somebody is writing it as negative x squared plus 9 equals 0, it is correct. But when the form of your equation, a as the leading numerical coefficient should not be equal to 1. So therefore, we should multiply negative 1 and we will get x squared minus 9 equal to 0. The same. Okay? Now, let us continue. We have x squared minus 9 equal to 0. Factoring, we have x plus 3 times x minus 3 equal to 0. Okay? Difference of two squares. You can check using your FOIL method. X times x squared. 3 times x, we have 3x. X times negative 3, negative 3x. 3 times negative 3, we have negative 9. Middle term, the middle term will become 0. And we have left x squared minus 9. Okay? To continue, we have x plus 3 equals 0. And, okay, so let us continue in this side. X plus 3, x minus 3 equals 0. Then we have x plus 3 equals 0. Then x minus 3 equals 0. Each factor is equated to 0. Then we have x equal to negative 3. And we have x equal to positive 3. Okay? Now let us check. Okay, so to make it more simple and easy, we will disregard x. We will just check for us to learn it better. So let's try to put your solution here. X is equal to 3. And we have x is equal to negative 3. So I will erase this thing. Okay, so checking. First, let us solve or check using x equal to 3. So we have log of x plus 1 base 2 plus, I'm copying the original equation, we have x minus 1 base 2 equal 3. Then substitution, x is equal to 3. So let us check whether x equal to 3 will satisfy your logarithmic equation or not. So therefore, we have log base 2, substitution, x is equal to 3 plus 1 plus log base 2, x again equal to 3 minus 1 equals 3. Then simplifying, we have log of 3 plus 1 is 4 base 2 plus log of 3 minus 1 is 2 base 2 equals to 3. Okay? Then, we have this one. Log 4 can be expressed as 2 squared. Then the base is 2. Then we have log of 2 base 2. Then copy 3. So we have this property number 3 on the properties that we have discussed. So the bases are equal. When the bases are equal and there's the exponent, then the answer in here is the exponent. Plus, when the log of a number and the base are equal, the exponent here is 1, therefore, correct answer is 1. So 2 plus 1 is 3 equals 3. Because 3 is equal to 3, therefore x equals to 3 is the solution of your logarithmic equation. Now let us check the another value of x, which is x equal 3. So we have to substitute right away. Negative 3 plus 1 plus log base 2 negative 3 minus 1 equals 3. Simplifying, we have log base 2. Negative 3 plus 2 is negative 2 plus log, then base 2 negative 3 and negative 1 is negative 4. Okay, it will be undefined. Undefined because we have a negative number. So log of negative number, a negative number is undefined. Okay, again, the log of any negative number is undefined. So therefore, x equal to negative 3 is not a solution. Okay, so x equal to 3 is our only solution to our logarithmic equation, which is given on. Okay, for our last example, we have log of 256 base 2 base x equals to 3. Okay, so to make it easy, let us simplify it one by one. Okay, so let us simplify first what's inside the parentheses. So the parentheses is log of 256 base 2. So we have to factor out 256. Let us try 16 times 16. So using your calculator, multiplying 16 times 16 is 256. Then we have 4 times 4 is 16. Then we have 4 times 4 again, that is 16. Then we have 2 times 2 as the factor of 4, as well as 2 times 2, 2 times 2, and 2 times 2. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8. So we have 2 multiplied to itself 8 times, or we have 2 raised to 8 is equal to 256. You can check using your calculator. So we have log, then base 2, then 256 again is 2 raised to 8. So using, I will erase this thing. Using property number 3, because the bases are equal, so the bases are equal. So when the bases are equal, the answer is the exponent. So the exponent is 8. And that is property number 3. Property number 3 from the properties of your logarithmic equation. Now let us simplify as log of 8 base x equals to 3. Now let us write it on the exponential form. So the base, our base in here is x. Then the answer of your logarithm is 3. And that 3 is your exponent equal to 8. So we have written it into exponential form. Right? Now let us extract your roots. Extracting, we have, so we extracted 3, so we will extract 8. So therefore we have x is equal to 2. Okay? Or we have this thing. On basic rules of exponent, we have x cubed equals to 2 cubed. Then extracting, we have x equal to 2. Or right away, you can input on your calculator the cube root of 8 will give you the answer of 2. Now let us go to checking if x equal to 2 is a solution or not. So using log, your original equation, log of 256 base 2 equals to 3. So again, let us simplify the logarithm inside the parentheses. So logarithm inside the parentheses is 8. So we have 8 equals to 3. Applying the third property again, we can write 8 as 2 cubed. Okay? 2 cubed equals to 3. So checking, the value of our x is equal to 2. Substitution, x is, so in here, okay, substitution. Now we have to use property number 3 again. The bases are equal, which is 2. Therefore, we will copy 3. And we did not touch 3 in here. So is 3 equal to 3? Of course they are. Therefore, x equal to 2 is our solution. Okay? So I guess that you have learned something from this video. Thank you so much. Please subscribe.